This year, NASA is using robot tentacles on Astrobee aboard the ISS, and it's already showing some serious potential on their ability to manipulate objects. But at the same time, we're also seeing the rise of humanoids, with tech giants like Tesla, Figure.AI, and Unitree racing to perfect their robot to walk, grasp, and interact like us. So why is NASA betting on tentacles when everyone else is focused on robots that look and move like us? What's even more telling is that NASA has slowed down its efforts on Valkyrie to focus on more specialized design for certain tasks. And it's not just NASA. From medical devices to deep-sea exploration, robotic tentacles are making their way into multiple industries. So why choose tentacles when humanoid hands seems like the obvious choice? First, let's take a look at the different ways robots can grab things. There are a few main ways to do it. You've got the classic claw-style gripper that everyone hates because we've all had our hopes and dreams crushed by these arcade machines. Very simple, but as we all know, they struggle picking up odd shapes. Then you have parallel grippers, which open and close in a straight line. Good for firm, basic-shaped objects, but not much else. And of course, the human hand option, which offers the more versatility in objects it can grasp and tasks it can execute. If we map this out, we can start seeing some interesting trades-off. But one thing I need to point out is that human-like hands are the most difficult grippers to design and control. It's taking years for engineers to develop a reliable way for robots to learn how to grasp. Take the agriculture industry, for example. A human hand instinctively knows how to grasp a tomato. But for robots, it's not that simple. Should it approach the tomato from the top or the side? How much pressure should it apply? Should it compensate for weight? Is the tomato even perfectly round? And what if it's already slightly squished? And tomato is crushed. Too late. It's almost like robots have to learn how to grasp each object one by one, figure out the right approach every time.
Think about the human hand, one of the most complex structures in the world. 29 individual bones, 34 muscles, 48 identifiable nerve paths, all connected to the most complex computer in the world, the human brain. We've spent decades trying to recreate a robotic version of the hand, and we continue to be frustrated.
What if we've been using the wrong tool all along? We might not need all that precision in the first place. Think of an octopus. It doesn't pinch or grab like a hand. It wraps, conforms, and holds securely without crushing. They're flexible, adaptable, and unlike hand gripper, they don't need to figure out the right way to grab something. They just do. And this is exactly why we're looking at tentacles for robots. But how do they actually work? Let's break it down. Instead of relying on the usual gripper toolkit with motors, sensors, and complex feedback loops, engineers took a creative approach with material science. Taking inspiration from octopus, they started using soft, flexible materials like silicone or rubber to create tentacle gripper. The tentacles wrap around the object and inflate or curl. Unlike robotic hands, they don't need cameras or algorithms to analyze what they're picking up. Take Harvard's tentacle gripper, for example. It's literally just a bunch of thin rubber tubes. But here's the trick. The material is slightly thicker on one side than the others, so when you pump air into it, it curls. The curling motion is what lets it wrap around an object, holding onto it without needing any real decision-making. And that's the key difference. A traditional robot has to think about how to grab something. It needs to know the orientation of the object, how big it is, how much pressure it should apply, all before it even moves. But a tentacle gripper, it doesn't even care. It just wraps around whatever it's in front of, adapts to the shape naturally, and holds on. Whether it's a fragile piece of fruit or a weirdly shaped tool, it just works. No crushing, no slipping, just a secure grip, all because of how the material bends and conforms. So in a way, it's not really about grabbing at all, it's more like hugging the object into place. By now, you have probably guessed that these robots' tentacles are useful for the agriculture industry. But where else can they make a difference? First, let's take a look at the medical industry. Imagine tentacles robots being used in surgeries. A robot small enough to fit inside your lungs, gently exploring the most delicate parts of your body. It sounds a bit much, I know, but hear me out. There is this tiny robot, which is only 2 mm in diameter, developed by Storm Labs at Leeds. It can reach some of the smallest bronchial tubes in the lungs to take tissue samples or deliver cancer therapy. This one is still in development, but you have others already being used that can safely handle delicate tissues or organs during minimally invasive procedures. Now let's look at underwater exploration. The ocean is a challenging place for robots. Think of high pressures, limited visibility, and the need to manipulate delicate marine life or sensitive equipment. Traditional robotics tools are not effective for this. Soft tentacle grippers, however, are a good fit for the task. MIT's underwater soft robot is designed to handle everything from delicate coral to sea creatures gently without causing harm, making it ideal for underwater missions. And finally, let's head into space, back to Astrobi, the free-flying robot on the ISS. NASA has been exploring how soft robotics can help with delicate tasks like gripping fragile objects and tools in space, but it goes beyond that. Space companies are also looking at how robot tentacles can be used to service satellites. Most of today's satellites aren't designed with grabbing in mind. They don't have grappling features for robots to hold on. This is where robot tentacles could make a significant impact. With all of this potential, could robot tentacles be the next big thing? Will we see these robot tentacles becoming more common in everyday tech, or should we just stick to classic humanoid designs? I'm curious to know what you think, let me know in the comments. If you enjoyed this, make sure to check out my latest video on how space robotics is opening up to everyone.